Hello and welcome to today's video on reinforcement learning. So just to give you a quick introduction on what reinforcement learning is, reinforcement learning is roughly about how to play games. So reinforcement learning, the concept in itself is nothing new. It's really this paper back in 2013 that really made things interesting. So let me just show you what this paper is. It wasn't playing Atari games, right? So they trained this neural network to play a whole bunch of different Atari games, and it got to the point where it's actually beating human level of expertise, right? So and that really got a lot of deep learning researchers interested in this area. Elon Musk actually invested in OpenAI, which actually plays a big part in reinforcement learning research these days. And quite recently there was AlphaGo and AlphaGo Zero, which effectively was beating the human world Go champion so far. So again, just to give you a technical overview, it's the closest we've gone to general AI. It's about learning how to do a task by repeating an experiment over and over again. Okay, so because computers can simulate experiments, the key ingredient that we need is a reward function. Okay, so one of the biggest problems of reinforcement learning so far is figuring out what is a good move in a given game. So for example, chess, you're always sacrificing pieces to get to a checkmate, right? So if you have a reward function that gives a -10 and all you care about is the current point in time, then you will never get to a good solution, okay? Because you will never sacrifice a piece, you will never be able to be, say, a chess champion. So this is where Bellman's equation comes in. Okay, so this Bellman's equation. Let me quickly write down some of the maths that is needed to understand this. Okay, so here we have the Bellman equation that I've written down. So this is called a quality score. Okay, so it depends on the current state S and the action. Now, if you're familiar with reinforcement learning, a lot of people tend to write this ST, AT, but I'm going to avoid that, and you'll soon see why. Okay, so it's a function of S and the action A. Okay? And then we have the reward that we achieve at that point in time. But we have this thing called gamma. So gamma is the discount factor. And then what we're going to say rather, is the quality score is the current reward plus a discount times the maximum quality of the next time step. Okay, so as soon as I take an action AT at my current state, it will lead to a new state S. Okay, so this new state is the state that we end up is known, but the key thing is that we're going to take, from all possible actions, we're going to take the maximum action that maximizes this thing, maximizes this part. Okay, and then we multiply that with a discount and then add that to our reward. Now, one key thing that you really ought to notice is that this kind of recursive, right? So this Q over here, I can expand that out as well. So depending on what the action is equal to the reward that you get for that particular action, plus gamma times maximum of the future next time step, and the quality score of this thing. So it can keep going forever and ever. Okay, so one problem is we don't know what this Q thing is, right? So what we need to do is we need to estimate it. And what do we do when we try to estimate? This is where machine learning comes in, right? So Q is really what we're going to try and approximate in our machine learning problem. All right, so let's go back to our code. All right, so in this tutorial, what we're going to be doing is we're going to be doing this problem called cart pull. All right, so it looks like this. So the goal over here is to balance it on the cart for as long as possible. So if I run this, let me just go right to start. If I run this, so what it stops because it's gone beyond a certain angle and it's dropping. So it stops the game over there. Okay, so yeah, that's as far as it's gotten. Yeah, so the key task is to keep it on the cart as long as possible. And this is where we're going to be learning about deep Q learning. All right, so let me go through the pseudocode, which I borrowed from this GitHub repo, Deep Flappy Bird. Everyone should go and take a look at that. So we're going to play the game over and over again, right? So OpenAI is going to provide us the environment, and